Hello. Today we're going to talk about topic 2, section 4, key features of graphs. Okay, so this whole section is just about the vocab. All right. Now, this function we have, it is increasing, all right, because how we read a graph is, think about a person walking along the graph and they're going from left to right. Okay, this is how we always read a graph, left to right. So this person is going further and further up a mountain, so that's increasing. Okay, so as x increases, then the function is increasing. All right, whereas in this one, this person is going down, okay, and that is decreasing, okay. All right. Also, you want to know about maximums and minimums, okay? You have local and global, all right? The difference between the two is, well, first, you need a maximum is when you have the left side is increasing, right? Because we're going up, and the right side is decreasing, okay? So it's like having a positive slope on the left side and a negative slope on the right side. That is a global, or that is a maximum. Okay, that defines maximum. Now, the difference between a local and a global is, a local just means that around it is going to have that positive slope on the left side, negative slope on the right side. But global means overall. Like, look at the entire function. That is the absolute highest it gets. So global is like overall. Okay. A minimum is when you have a slope of something negative on the left-hand side, so that's going down, and on the right-hand side, it is increasing, okay, like a positive slope, okay? So let's do an example. So we want to find these turning points, okay? That's another name for maximums and minimums. So we get out our calculator and we go to our y equals, and this screen should pop up. So you type x cubed, so you need the caret symbol, then hit right, so you get over, get minus 6x squared minus 7x minus 6. So we graph this. Okay, so here we have 1, we have a maximum here. So here we can go ahead and find that maximum by doing second trace. So do number 4, do the left-hand side of it, do the right-hand side, and guess. And there we have our maximum point. Now that's going to be a local because we can see that the graph is increasing over there. So there's got to be a higher point. So that is a local maximum. So there's at 1 point. But we need the rest of it. So we need to adjust our window. So I'm going to do, let's see, I want to increase the y's. I want to go further down. So instead of negative 10, let's do negative, well, let's do negative 25. Ooh, we really got to go out. Okay, so let's do negative 50. And it's just a bunch of guess and check. I'm still not there. Okay, so we adjust our window again. Let's see, third time's a charm, right? Let's do negative 75. Oh, there we go. All right, so now we have a minimum. So we do second trace and do number 3. And then we're going to do, uh-oh, I think I messed that up. Sorry, let me try that again. Do second trace. Okay. Left bound, we always start with left bound. So let's see. I'm gonna do here for left, here for right, and my guess. There we go. So then this is my minimum, all right, on my calculator. So let's check it, see how it did. And yep, those are the points that we got. All right, and we know that it's going to have 2 turning points, because I know some people are probably like, well, how do I know that it's just going to do this and it's not going to come back around? Okay, well, that has to do with the highest degree. So this is a cubic, all right, and the number of turning points is always equal to 1 less than the degree. Okay, so we know we found 2 turning points, so we know that's all there can be. All right, so now when we talk about sketching, we have to look for more things. Okay, we're going to look for our x and y intercepts, just like we did in the last lesson. And then now we're adding turning points, and then I'll show you some asymptotes as well. Okay, so we're going to look for these 4 things. So let's start with this one. So you want to put this into your calculator. Okay, and then you want to mess around with the graph. So feel free to pause the video and see if you can find the turning points, and then you sketch it on your paper. Okay, so now this is what I'm looking for on your paper. Now I don't know why Cognitive does this, but I want arrows on yours because I want you to know that it goes on forever. Those aren't ending points. So we found the y-intercept, the x-intercepts, the minimum. Okay, so this would be considered a global minimum. All right, and we know that this is all it has because the highest degree is 2. So 2 minus 1 is 1, so there's 1 turning point. All right, try another one. So go ahead and plug this into your calculator, see if you can do a quick sketch of this. So pause it. All right, so this is, trash can's over here. So this is what Cognitive draws. Now I want you to put arrows. Found the x-intercepts, y-intercept, and what's nice is that one of the x-intercepts was also a local max. Right, that's a maximum, like a hill, and it's not the highest because I've got more points over here that are higher. Now over here at 1, -4, that is a local min. Right, it's a minimum because it's like a valley, and points over here are much lower. Okay, try this one. So, oh, I don't think I mentioned this in the last one, the number of turning points again. So 3 minus 1, so there are 2 turning points. which means there are two max mins. All right, could have been two maximums, could have been two minimum. Well, no, no, not with the way we're doing it. So, but at least this way you can count them. All right, so then this one, go ahead and pause the video, try this. All right, so lots of things here. You have a y-intercept over here, and that's easy to plug in because remember your y's are just, your x's are just 0. Okay. And then you have your x-intercepts, so 3 of them. You have a local max at here, and right here you have a local min. And again, put your arrows. All right. So hopefully this is making sense with your calculator. This is how you show your work. Don't just put it in your calculator and say, okay, I got it. No, write it down, put a sketch in. Okay. All right, so for horizontal and vertical asymptotes, we want to make sure we understand this. So this is how they explain it, right? The fancy wording of it all. So let me explain what this means. So as x goes towards infinity, so as x goes this way, so as we go this way along our graph, so as we're going left to right, we're here, notice my y value suddenly starts to taper off and get close to a certain value. So here, as x is increasing, so as x goes towards positive infinity, f of x, the y part, is approaching -1. Notice it's not equal because you can't equal infinity. You can't equal -1, but we're getting close to it. Okay? So then for this one, as x is going towards negative infinity, well, negative infinity is to the left. So as I'm going this way along my graph, so now it's telling me kind of go in reverse direction, all right? Go towards the negative. So now my guy is going this way on my graph. And as my figure is going this way, right, my graph, my y, is approaching -1. So for the left side of the graph, as x approaches the left side, the y is approaching -1. Right, so that's how you write the horizontal asymptotes for these. Okay? Or that's how you describe it. Okay? So the horizontal asymptote here would be y equals -1. Or I'm sorry, y equals +1, I'm guessing, or y equals 2. Sorry, didn't see that there. Okay, so here we're going to sketch this, and then we're also going to include the asymptotes. Let's see if you can find it. So you put it in your graphing calculator, and you should see it approaching these lines. And we can do that with the trace function. So how I would type this into my calculator is I would do this part, so 1 divided by, well, I'm putting it in parentheses, but I want to put the denominator's got a lot going on, so I'm going to put another set of parentheses. So x minus 1 for the denominator, and then a second set of parentheses to contain the fraction. And then we're going to take that fraction and subtract 1. And then just in case my window is weird from before, I'll do zoom standard. So we use the trace function, and we can just follow our graph. as my x is increasing, so it's at 0.6, then 0.75, then 0.9. All right, it's a little after 1. Oh, then notice I'm over here now. Okay, so if I have 1, I'm going to have an issue, right? Because think about it. I have a restriction here. X minus 1 can't equal 0. So x can't equal 1. Well, hey, look what my vertical asymptote is. All right, so your vertical asymptote can come from your domain restriction. Okay, that's one way to get it. All right, and then for the y, all right, so for the horizontal asymptote, as we go further and further out, so go all the way to the extremes, to the y's, right? My y value is getting closer and closer to -1, okay? And I kind of want to just think about like plugging in a huge value. So that is the Bill Gates rule. So if you have 1 over, well, a billion minus $1, I'm pretty sure if I'm a billionaire and I drop $1, I'm not going to care. So now we have 1 over a billion. So 1 over a billion minus 1. Well, 1 over a billion, that's practically nothing. That's point blah, 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 1, right? 0, 0, 0, 1, whatever, how many zeros. So this is practically nothing minus 1, which is roughly -1. And notice that is how we got our horizontal asymptote. So that's one way to think about it too. You're trying to figure out what y is approaching. So you plug in extreme values. So plug in a billion or -billion. Okay, so that's how we get the horizontal asymptote. So that was y equals -1. And that was x equals 1. All right. So let's see, how many asymptotes are there for the function? Well, we plug it in, we look. There should be 2. Hopefully you see it. Okay, the equation of the horizontal asymptote. So that's going left and right. So think about it, horizontal, left and right. So that's extreme values. So plug in a billion. That's the Bill Gates rule. So 2 over, well, a billion, because again, if I drop $2, who cares? So 2 over a billion plus 1, well, that's just practically nothing, right? So 0 plus 1, so my horizontal asymptote, my left and right, should be at y equals 1. Okay, and my vertical, that's when you go left and right. So remember, that's your vertical line test. So that means that I can't have, I'm going to have a domain restriction. Okay, well, the only time I have a domain restriction is in my denominator. So when x minus 2 is 0, that's an issue. So when x equals 2, that's my vertical asymptote. Okay, so hopefully you were able to figure that out with your calculator as well. Okay, so let's do the intersection of 2 points. So that's another way of solving equations. So if we want to know what point will satisfy both equations, well, we could just set them equal and solve. Okay, so we could do that. We could do x cubed minus 1/2 x squared plus 1 equals x squared plus 2x minus 1. Move things over to the other side and then try to either factor the quadratic formula or the poly simulation app, right? But here's another way, okay? we can do the intersection. So I want you to put these into your calculator. So put that as y1 and put g of x as y2. Okay, so I put those into my calculator. The blue, blue equation matches the blue graph, red equation matches the red graph. So I kind of want to see a little bit closer because it's hard for me to see what's going on. So I'm going to eliminate this side and this bottom part, right? Kind of zoom in. So I want my y value to not be so low. And I want my x values to be further in. Let's do -5 to 5. Okay, so now you want to find the intersection points. So we do second trace. We do number 5. And so we're doing our guesses. So do the blue curve, right, because it says first curve. So I'll do that guess. Then do the second curve. Okay, try it. Okay. Close enough. All right, so we get this as one of our intersection points. -1.28, -1.92. Then you do it here for that intersection and for this intersection. Okay, so if you do it for all three, you should get these points. Okay, and you can see that was the first one we got. Okay. All right, so hopefully this makes sense. Okay, if not, go back, rewatch it, or come see me in class and ask all the questions you want.